Today is our second day. We're solving inequalities by addition and subtraction. Today we're starting off with the word problem. It says Paul wants to buy season passes to 2 theme parks. If one season pass costs $54.99 and Paul has $100 to spend on both passes, the second season pass must cost no more than what amount? This is a great word problem to do because this really is real life. You want to spend things, whether you're going to an amusement park or to the mall or to the movies, and you only have a certain amount of money to spend. You have to try to decide what you want to buy or what can you buy with a certain amount of money. So let's take a look at this. It says his first season pass is $54.99. So let's write that down. $54.99. And we don't know how much the second season pass. So that's going to be plus or X. But together, he has only $100 to spend. So I can spend less than or equal to $100. All this on the left has to be less than or equal to 100. It can't be more. It can be 100, but it can't be more than that. So now I'm just going to solve my inequality like I have in the past. I need to get X by itself, so I'm going to subtract $54.99 from both sides. So I know that X is less than or equal to $45.01. Now, this is a word problem, so I have to make sure in the end that I'm answering this. And the question asks, the second season pass must cost no more than what amount? So I'm going to write a sentence. The second pass must cost no more than $45. Now that dollar sign goes in the front. $45.01. So that answers my question. Our second word problem says the NHS freshman class can sell at most 485 tickets for the fall formal. After all the lunch periods today, they had sold 317 tickets. How many tickets can they sell before the deadline on Friday? So let's try to understand this. It says they can sell at most 485. Maybe that's all they can fit, but I can't sell anything more than that. And it says so far they've sold 317 tickets, and they want to know how many more tickets they can sell. So I'm going to have 317, that's what they've sold so far. And I'm going to put N for the number of tickets. You can use any variable. This time I'll just use N. And again, that has to be less than 485. They can sell 485, but they can't sell more, which is why there's an equal sign there, less than and equal to. So again, I'm going to isolate my variable. I get 317 by itself. And I have N is less than or equal to 168. Now again, we're not done because it's a word problem. So let's write this in a sentence. It says they can sell no more than 168 tickets. That would be my final sentence. I could also say they could sell at most 168, or they could say 168 and less tickets. There's a lot of different ways you can say that. But in the end, the most they can sell is 168. Now we're going to translate some verbal statements into some inequality statements. And in doing this, it does get tricky between the addition and subtraction and inequality. So we want to take a look at this. Addition, when we're looking at that, here's an example. It says a number more than 6 is 12. So a number more than 6 is 12. Remember, is means equal in math. Let's look at the inequality statement. It says 3 times a number is more than 9. So that word is important. So 3 times a number, that's my first term, 3 times a number, is more than, greater than. It means it's more than 9. So this side of my inequality is more than 9, which is where I get a greater than sign. In number 2, it says 3 times a number is at least 9. So 3 times a number is at least 9. So this time it means that I'm including 9 in my inequality. So this is going to be greater than or equal to 9. 3 times a number is at least 9. As we move on to comparing more, we'll look at subtraction. So I have 10 less than a number is 22. So 10 less than a number, that's my first phrase. 10 less than a number is means equal in math is 22. So it says 10 less than a number is 22. If we look at our inequality, I have a number decreased by 7. So this is going to be a number decreased by 7 is less than 17. So there's my less than symbol, 17. So a number decreased by 7 is on the left, and then is less than 17. And comparing that to number 2, it says a number decreased by 7, so that's going to be the same, is at most 17. So this one is saying that my value could be 17, but that's the highest value it could be at most. So that's why in this statement I have a less than or equal to. Now we're going to combine translating our verbal statement into an inequality along with solving. So my first one says twice a number is more than the sum of that number and 9. So let's go back. Twice a number, I can use x or n, any value I want, is more than, so there's my greater than, it is more than, this side here is more than the other side, the sum of that number and 9. So the sum of that number and 9. So let me go back and read that just to make sure it looks like I did it okay. Twice a number is more than the sum of that number and 9. So my inequality statement looks pretty good. So now I'm going to solve. There's my wall. I'm going to isolate my variable, get my x by itself, so I'm going to subtract x to both sides, and I have x is greater than 9. So what that means is all values that are greater than 9 are solutions to this inequality. It could be 9.7, 10, 12, 13, but again, in this case, it does not include 9. And looking at our second problem here, it says 7 times a number minus 3 is at most 6 times a number and 25. So let's break that down. 7 times a number minus 3. So it's 7 times a number minus 3 is at most. So is at most. So that's less than or equal to 6 times a number and 25. So let's go back. 7 times a number minus 3 is at most. So it's saying this point right here is at most what I have on the right-hand side, 6 times a number and 25. So now I'm going to solve it. So there's my wall. I'm going to subtract 6x from either side, and I have x minus 3 is less than or equal to 25. I need to add 3 to both sides, and my final answer is x is less than or equal to 28. X is less than or equal to 28.